Okay, so we should be good from there. All right, so today's November 18th, and this is section 4-5. Okay, so we are definitely all day today, we're going to focus on sine graphs. And then we will just barely touch on cosine because they are so similar. Okay. So in general, I'm not going to assume that you all took physics, all right, because you may or may not have. And even if you did, I don't know how much you did with sound waves or what exactly was in that physics course. So we're going to just, in general, just kind of talk about waves in general, because you've got to know some terminology to be able to do anything with your sine and cosine. All right, so let's just say that this is sound waves, just in general, for some vocab. All right, now I am going to kind of draw this like we're going to do it. We're going to be on our coordinate plane here. For the most part, sound waves, just in general, sound waves what go on forever and ever and ever in both directions. So that means our sine and cosine graphs are going to do that exact same thing. All right, if you have taken a physics class where you've been exposed to some of this, all right, what are the graphs? They are wavy things like this, and then they just repeat over and over and over and over and over in both directions. Okay, so I've just drawn here what is referred to as one period. All right, so from this point to this point would be considered one period. All right, so what that means is that the graph started here, it went up, it come back down, and then now I'm back to the x-axis, and the pattern will repeat. So it's going to go up and then come back down. So when the pattern starts to repeat, that's your period. Okay. The other vocab word that you need to know is the distance from the x-axis to the peak right here. All right, so from this point to this point right here, and that is referred to as the amplitude. So those two things are consistent. It doesn't matter whether you're in a math class, you're in a physics class, those things are going to remain the same. Okay. So just basic vocab for anybody that has not been exposed to that yet, because I will refer to both of these with formulas later on and when we sketch our graphs. All right, now let's take a look at, from here, just a basic sine graph. And I may do the correlation with sine and cosine together just so that we can see it here. All right, so let's do sine graph. Okay, I think I am going to do that. Let's do a side-by-side comparison. I think that might be good. Okay, sine graph. Cosine, sine. I probably should have spelled this out. If I spelled this word out, I probably should have spelled this word out. There we go. All right, now basic graph. All right, obviously we know, because we've done this with parabolas and cubics and absolute values, that we have that base graph that's not shifted away from the origin. And then we can shift, because extra numbers are put with the equation. It can be shifted up or down, left or right. Okay, so again, I'm going to take a look at this basic graph with no shifting. Okay, and I'm going to be very detailed in the way I label this. All right, so I'm going to use quadrants 1 and 4, because I'm only going to draw one period of this. All right, now a basic sine graph that has no shifting, no stretching, no compressing, none of that going on. All right, I'm going to say this is 1. I'm going to say this is -1. It has some key points, about 5 key points along the graph. It takes, to draw one period, it takes 4 hash marks. So 1, 2, 3, 4, and I'm going to try to space those out. All right, now a basic sine graph, one period is 2 pi in length. So this would be 2 pi. All right, now stop and think about this. Is from here to here is 2 pi, then halfway in between would be pi. Again, I'm labeling these parts. All right, again, if from here to here is pi, then this would be pi over 2, or half of pi. All right, now to come up with this point right here, if this is 1/2 pi, and then 1 pi, all right, or 2 pi over 2, then this would be 3 pi over 2. Okay, so when we do these by hand, or even when you're looking at these in Math Excel, these are going to shift. These points are going to shift, because this is a basic graph, so I know my period is going to be 2 pi. But as soon as I stretch this or compress it, all right, my period is going to change, which means then these 4 points are going to change, because the distance between here is going to differ. All right, now sine always starts at 0, 0 and goes up. So it starts at 0, 0, it goes up to a height of amplitude of 1, that the base graph does with no stretching, compressing, comes back down, goes through pi, comes all the way back down here at -1, and then comes back up to here. Okay, so I'm not gonna play connect the dots because I know this graph goes on forever and ever in both directions. Okay, but we come up here, this would be the basic sine wave. And again, I'm going to keep going. All right, but one period is from here to 2 pi. Now, every sine graph starts right here at 0. Okay, without the shifting, of course, and then goes up. Okay, that's how you're going to tell the difference between sine and cosine. So let's go ahead and do a comparison side by side of our cosine. Okay, so again, this is a basic graph, no shifting away from the origin, no stretching, no compressing. All right, so I'm going to set it up the exact same way. I'm going to use that first and fourth quadrants. I'm going to have an amplitude of 1. All right, and again, 4 equal hash marks. All right, basic cosine graph, one period, no stretching, no compressing, all right, is again 2 pi. So then these are going to be labeled the exact same way because halfway in between would be pi, halfway in between here would be pi over 2. You'd have 3 pi over 2 here. All right, now the difference between these two graphs is cosine starts at 1. The amplitude is up there, okay, and it comes down and comes through pi over 2, and then comes down again, okay, comes back up, all right, and then comes back up. Let's see how well I get that point on there. All right, now again, I don't want to play connect the dots, and this is not a V, all right, we know these are waves, we know they're sine waves, all right, so I'm going to kind of, we know it would come down here, it's going to peak, it's going to come back up there, and then it would keep going. Okay, so that's the difference between the two graphs, and that's how you tell the difference. Now, when we start translating these left or right and up and down, you know, you are going to have to do a little bit of thinking and not jump to any conclusions. But for the most part, that's the difference between the two. Everything I do today for sine is going to correlate for cosine. Okay, the difference is, well, where am I going to start my graph when I sketch these? Okay. All right. Now let's go back and get some other things that we probably need to know about this. All right. In general, I'm going to write the equations for this basic graph with my A's and B's like I have done with our parabolas and cubics and those things. So I have given you in the past things like, let's write it up here. Y equals a negative A sine BX. Okay. We're used to me writing things like that. All right, now this negative, all right, when there is a negative in front of that, when that's a -2 or a -3, what that tells me is it's going to, the graph's going to reflect, and I don't necessarily want to say reflect across the x-axis. I mean, if it's this and it's not been shifted away from the x-axis, yes, it's going to reflect across that x-axis, but in other words, it's going to reflect top to bottom. So let's refer to it as that. All right, so it's going to reflect top bottom. Okay, and we're used to this. We are used to the negative on the cubic flipping left to right. We're used to a negative on the parabola, making it an upright parabola versus an upside down. So same thing. All right, and then again, if I have said something for this graph, all right, then it's also going to correspond for your cosine. So I could go ahead and add that over here as well. Y equals negative A cosine BX. All right, and again, that negative A there, that negative is going to do the exact same thing. Okay, so reflect top bottom. Almost running out of paper there. Okay, now something else. We have done domain and range of graphs for a long time. If this graph goes on forever and ever in both directions, then I know that means that my domain is going to be what, negative infinity to positive infinity, using that interval notation. All right, even though I may only be drawing one period, the domain goes on forever in both directions. Okay, now, since this clearly is oscillating behavior, all right, that amplitude is 1, all right, and then -1, it's going to go back up to 1. It's going to go back down to -1. So it's oscillating back and forth between 1, all right, on this base graph. All right, if we write the actual equation of this base graph, let's write it right here. It would be y equals sine x, okay? All right, now, I just said it's oscillating between 1 and -1, okay? If this is the actual equation for this graph, okay, without my a and b, you know, ones everywhere, no shifting anywhere. All right, what? There's an imaginary 1 right there. All right, that a there, when we take the absolute value of that a, that's going to give us our amplitude, okay? So I'll write that formula down here in a minute. But what I'm trying to get at is here, since I'm doing domain and range, the range is going to be between -1 and 1. So on this particular one, I'm going to be very specific, and I'm going to say it's between -1 and 1. All right. However, as we just saw, this coefficient is going to give us that. So in like a generic formula way to write it, the range is going to go from -a to a. Okay, so let's just make that little distinction. All right, now we are going to have some formulas. All right, I talked about the amplitude. You got to have a way to find the amplitude of the graph because it's not always going to be 1. Like it's going to stretch, it's going to compress both left and right and up and down. Okay, so my amplitude, I'm going to abbreviate because I'm going to run out of room here. My amplitude is the absolute value of my a value. So whatever that a is, I take the absolute value of it, and that's going to tell me how high or what the amplitude of the graph is. All right, now I said on this base graph, your period is 2 pi. All right, but if it's been stretched or compressed left to right, you're going to have to calculate that because the period's going to change. So the formula to do that, I'm going to do PD for my period there, is going to be the formula 2 pi over b. All right, so again, these two formulas are the formulas that we are going to use on a regular basis. All right, now, not that I need to take the time to write all of that stuff down. All of this matches over here as well, okay? Cosine graph is going to have the exact same domain. The range on the base graph, let's go ahead and write the equation to the base graph here, y equals cosine x. That's the actual equation for what I have sketched right there. All right, the range would be from -1 to 1, but generically it's going to be -a to a. All right, these two formulas again apply to both. So if I had a cosine graph, I wanted to find the absolute value. If I wanted to find the amplitude, I would take the absolute value of that a coefficient. All right, if I wanted to find the period, I would do 2 pi divided by whatever the b coefficient would be. All right, so that's why there's so much so much in common with both of these. All right, now for the most part, if you're doing homework assignment by hand where you've got to write out the questions, then you're going to sketch this. If you don't draw them to scale, then every one of your sines would look like this. Every one of your cosines would look like this. And the only difference would be the numbers. All right. So being able to draw them to scale is important, but also just being able to, if you could not necessarily draw it to scale, but definitely tell me what those two numbers are for the amplitude, and definitely tell me what those 4 numbers are, then even though maybe you didn't have it drawn to scale, I could still tell that you had graphed it accurately because the period would be right, the amplitude would be right, and then these 4 numbers would be calculated correctly. Okay, now you're not going to have to worry about in Math Excel, they're going to give you the graph. You're not going to have to graph it. I don't think you have to graph any of them in there, but you're going to have to be able though to find your amplitude and your period, and then it might be a multiple choice scenario. So then you're going to have to match it up. All right, and then see which one works. Now, so that you can actually see what the compression in the actual to scale looks like, we are going to do one to scale. we're going to sketch one not to scale because I want to show you how to calculate the amplitude, show you how to calculate that period because we need those numbers. And then we're going to take this exact same graph that we just do and do it to scale. Okay, so let's say for this first example, it's going to say sketch. All right, so in other words, I just used the word sketch. So then this first one I do is not drawn to scale. All right, I just want to get it to where you understand where all the numbers are and what we're doing with this kind of stuff. All right, so let's suppose I have the equation y equals 4 sine 2x. All right, and sometimes there's a parentheses around that 2x, and then sometimes I don't put it there. And usually in a typed situation in a textbook, they probably are always going to have that there. Okay, so the thing that we're going to look at is we're going to first identify the amplitude. Okay, so our amplitude was what? We had a formula for the absolute value of A. That was our formula. Okay, here's my A variable. Here's my B variable. Okay, so absolute value of 4 is just 4. So I know my amplitude, this graph is going to go all the way up to 4. Okay, and corresponding down to -4. Okay, I'm also going to calculate my period. All right, what? We said the formula for that was 2 pi over B. Okay, so doing the math here. All right, 2 pi goes on top. B is 2. All right, and then can I go ahead and cross those 2 off? So this one has a period of pi. So where it starts over, the distance from where it started to where it starts over again is pi. All right, if I had to list the domain, I don't have to have the graph yet to know, because every sine and every cosine has the exact same domain, and it's always negative infinity to infinity. All right, now I can do the range without the graph, because what? I know it's going to bounce in between those amplitudes. And if I know my amplitude is 4, I know it's going to go all the way up to +4. It's going to come all the way down to -4. So my range has to be between -4 and 4. So I can do these just because I know how the graph is going to behave and act. All right, now we are going to sketch it over here. I'm going to do it relatively big just so we can see it, since we're in a Zoom meeting here. All right, now I need 4 hash marks going to the right. Okay, try to make them equally spaced. I mean, I know we're sketching, however. All right, now the period. It's going to start over here. It's going to end over here. My period is going to go from here to here. All right, if I know the distance from here to here is pi, halfway in between has to be pi over 2. Okay, now, how good are you with fractions? If from here to here is pi over 2, I need 1/2 of pi over 2. It's going to be pi over 4. All right, and if you needed to do the math, and like I said it, I don't know if you caught it or not, 1/2 of pi over 2. If you remember middle school, all right, means multiply. So multiply straight across the top, multiply straight across the bottom, pi over 4. Okay, so just a little bit of help there if you're struggling to get that number. All right, now the distance from here to here is 1 pi over 4. This would be 2 pi over 4, which would reduce to pi over 2. And then this is going to be 3 pi over 4. So once you know this, you're just counting. Okay, so then this becomes 3 pi over 4. And as you can see from that first base graph that I gave you, these numbers just changed. Okay, now I'm supposed to have an amplitude of 4, right? So 1, 2, 3, 4, -1, -2, -3, -4. All right, again, I'm not drawing this to scale. Clearly that one doesn't, I'm not drawing this to scale, just trying to sketch it out. All right, we know sine starts where? Sine always starts at the origin. So my first dot is here. All right, when I go up to over to my first hash mark, I got to go all the way up to get that amplitude of 4. It would come back down. It would hit pi over 2 at the x-axis. It's going to come all the way down. See if I can line this up pretty good. All right, and then it's going to come back up here. All right, so again, make it curvy. This is not connect the dots. It's supposed to be a sine wave. All right, so that's without drawing it to scale. Doesn't it look exactly like what we just did? All right, every one of them is going to look the same. If you don't draw to scale, they're all going to look the same. These numbers will change and this numbers will change, but for the most part, they're all going to look the same. So you really, really do need to draw them at scale so that you can see what's going on, so that you can see the compression and the expansion and how these things work. All right, now, since we know that this is 4 sine of 2 pi, all right, what I'm going to do is I'm going to compare this graph, because we know what this looks like, to the basic sine graph. Okay, and we're going to draw it to scale. Okay, so drawn to scale. Okay, we're going to do, let's see, I'm going to do this in two different colors. So let's do y equals sine x in red. All right, and then let's put the y equals 4 sine 2x in blue. Okay. All right, now we've already calculated all the stuff for this one, and we know this is your base graph, so we know what period and all that kind of stuff is. So again, I'm going to do this relatively big since we're in a Zoom meeting so that you can hopefully see this. All right, and I am making it kind of big because I want you to be able to see this compression. Okay, so let's do this one first. Okay, so our basic sine graph had a period of 2 pi. Okay, so what I'm going to do, I am going to put 4 marks on here. Let's do one, try to make them spaced out here. All right, there's 4 marks. Okay, so there's 2 pi. But at the same time, let's put some other hash marks in here. All right, if this is 2 pi, then this one's going to be pi. Let's just do that for right now. Okay, now let's put some additional hash marks in there. I'm going to try to make these longer. Now let's split that up. Okay. All right, I'm going to go ahead and put the red one on. Let's get that done and out of the way. All right. This would be 1, 2, 3, 4, -1, -2, -3, -4. All right, I'm going to switch back to red. Okay, that sine graph. Let's go ahead and pull up what I had done just a minute ago, just in case I need to refer to it. All right, it had a period of 2 pi, went through pi, had a height of 1, went down to -1. Okay, so I'm going to put my first dot red at 0. All right, when I go up, I'm going to go, because I've got to end here. So at pi over 2, I'm going to be at a height of 1. All right, when I come back down, I'm going to be at the x-axis at pi. All right, when I get back to this point, I'll be at -1. All right, and then I'm back here for my period. Okay, so that basic sine graph okay, so you can see not very tall, kind of spaced out this way. Okay, now let's go back and review some of the things that we had said about this. We said that the amplitude was 4. We said that the period was pi. Okay, well, here's pi. So when I put this graph on, one period is going to be from here to here. The second period is going to be from here to here. Okay, so it still starts at 0, 0. All right. But one period, I've got to think just between here and here. So I'm going to come up to my first one. I'm going to go all the way up to the amplitude of 4. Then it's going to come back down, hit here. It's going to have an amplitude that goes all the way down here and then back up to pi. That's one period of it. Okay. So let me see how well I can go through these dots. That's one period. Okay. Now, to equal because of the compression and the expansion of these. All right, I'm going to have to do this again. So I'm going to come all the way up. My next dot's going to be up to 4. If I keep going on this, if I come back down here, it's going to go through the x-axis. I'm going to come all the way down to the -4 and then back up here. Okay, so when you draw these to scale, then you can clearly see that some of them are compressed, like this one. It's been compressed this way, so I get more periods in. All right, it's been kind of stretched this way. So instead of just having an amplitude of 1, this one has an amplitude of 4, which makes it bouncing, the oscillating behavior bouncing deeper, longer. Okay, so I definitely wanted to do something drawn to scale here, just like we're doing this by hand, just so that you can kind of see the compressing and the stretching. Okay. Like I said, when you do these questions in Math Excel, I mean, they will draw them that they're going to be computer generated. So they will be to scale. Okay. So they're not just going to be what you're going to look like when you draw them by hand. All right. So for the most part, that's pretty much all there is to this. Let's do maybe one more where I've got a negative a. So I just want you to see what that's going to do to the graph. So again, I'm going to go back to sketching because I'm not going to draw each one of these to scale. So let's go back and say that we're going to sketch this one. All right. So it's not drawn to scale. Let's say I've got maybe say y equals -3 sine. And I could have done cosine as well. Okay, it just would be where I start. All right, so I already wrote sine, so let's go ahead and stay with sine. Let's say that this is pi over 3x. All right, so that's my b, that's my a. Okay, it's going to vary every time. This is a, this is my b coefficient. Okay, so to do a sketch here, I need two main things. I need my amplitude. So my amplitude is that absolute value of a. So absolute value of -3 is going to give me an amplitude of 3. Okay, if I do my period, that formula was what? It was 2 pi over b. All right, so if I plug in what my b is, that's going to be pi over 3. Okay, now remember what is this? Complex fraction. We've done this before. We multiply 3 by that least common denominator just to make it quick. So I can multiply the top by 3. I can multiply the bottom by 3. So those 3's cross out. All right, that's just some arithmetic that we have done early on in the year. So 6 pi over pi. And then what happens to those pi's? They cross out. So this one has a period of 6. And that's okay. I don't have to have very many measures down there. I can have a whole number. Okay, so just real quickly, a rough sketch here. All right, again, I'm just going to use quadrants 1 and 4 because I got to go somewhere. All right, my period is 6. So 1, 2, 3, 4. Just make them equally spaced. That's going to be 6. Halfway in between would be 3. Okay, this would be 1.5. All right, this would be 4.5. Okay, so labeling those points, I'm going to have an amplitude of 3. Okay, so 1, 2, 3. -1, -2, -3. Okay. Now, we know the sine graph starts at 0. So let's go ahead and put our thing there. All right. Now, the part that you've got to pay attention to is, well, what did that original equation look like? I've got that negative right there. All right. So that tells me that it is reflected. Okay. So let's put reflected just to help remind you. So in other words, this one is not going to go up and then back down. It's going to reflect. So if under a normal circumstances, sine would go up to here. Well, if I reflect that, it's going to go down. Okay, so the next point would be down here. I would come back up to the 3. I would go all the way to 3 on the x-axis. I would come up to the height of 3 here and then come back down. Okay, and then again, let's not really connect the dot. Try to make it look like a wave here. Okay. All right, so that's how that negative works. Okay, and like I said, I could have done this with cosine. I didn't do any examples with cosine. All right, but instead of starting at 0, if this would have been the exact same thing, but it would have been cosine. All right, well, cosine normally starts up here, but with the negative, it would have been reflected. It would have started here. Right, so pretty straightforward. I'm pretty sure on today's assignment, you're only going to be focusing on those sine graphs, but with the similarity between sine and cosine, I definitely wanted to do both kind of at the same time. Now, we do have to do one other thing. You are going to be given information about, say, the amplitude and the period, and then you're going to have to calculate the equation. All right, so let's take a look at that specifically, a different concept here, away from the graphs. Let's say the directions say write the equation of the sine function with the given characteristics. Okay, so they're going to ask you to write the equation when they give you a couple clues. All right, so if they tell you that the amplitude is 4, all right, that one's pretty straightforward because then you know that what your A is going to be right away. Okay, now they're going to tell you, maybe say that the period is 6 pi. That one is not going to be as straightforward. Okay. Now, the way we're going to do this, all right, is you're going to take a look. You're going to use that generic equation that I gave you at the beginning. So it was y equals, and then we don't know necessarily whether it's going to be plus or minus. So let's say plus or minus a. They told me sine, so I want sine, and then bx. That's that general equation right there, right? I need a, I need b. Okay, now, like I said, if they tell me my amplitude, okay, well, that's going to be relatively easy. I can do that right away. Okay, so I know it's 4, but I don't know whether it's positive or negative. So I'm going to start building my equation over here. I'm going to have a y equals, my amplitude is 4. It could be positive or negative. I don't know from what they've given me. I know I'm going to have sine. Now, the deal is I've got to find b. Okay, now, my period, okay, is equal to a 2 pi over b. This is an equation, right? It's a formula, but it's an equation. I know my period is 6 pi. So replace the period with 6 pi. All right. The formula over here is 2 pi over b. All right. Now I have an equation. All right. Can I solve for b? All right. Lots of different ways to do this. Could I multiply both sides by b? Okay. If I multiply both sides by b, I'd have a 6 pi b equals 2 pi. And then can I solve for b now? I can divide both sides by 6 pi. So if I divide by 6 pi, I divide by 6 pi. Those two cross out, pi's cross out. My 2/6 there can be reduced to a third. So my b has to be a 1/3. Okay, so knowing my original equation and knowing my formula, let's box this in. All right, then I can write an equation and I can solve for b, which means now I can come back over here and I can finish writing my answer. I know b is 1/3, so this would be a 1/3 x. So then there is the equation of the sine function that has an amplitude of 4 and a period of 6 pi. All right, so I definitely wanted to show that to you. This may not have necessarily how you find that b might not necessarily have been as intuitive, all right, as straightforward as it is for everyone. So one example there, because I don't think that's very, very hard. Okay, so does anybody have any questions?